cool. We're good. All right. So, and I see just myself, but that's cool. Yeah, I think what we'll do today is start off just by looking at the pull requests we landed. I think it was about 2 weeks ago now, where we kind of did the first start of this new entity framework thing we're working on. And to kind of start off, it's useful to think about or to talk first about like why we're doing this, what kind of some of the motivations behind it, and then the goals, like what are we trying to accomplish here. So I guess high level, so we've been working on hubs for a couple of years now. We started off building on top of A-Frame. A-Frame was super useful in helping us get a prototype out the door. There was lots of one of the most powerful pieces was like there's this huge library of community created components that we were able to really build something up very quickly. We had when we started on hubs, we had a kind of room with avatars speaking to each other up within like it was like a week.
Yeah, in VR with
Yeah,
hands, I think.
yeah. Yeah,
We use like networked A-frame and
yep.
super hands, and like a
Um,
basic object loader.
yeah, and we had it running, and we're like, we actually we're pretty skeptical we could even do this in a browser. We a lot of us when we started, we had come from a Unity background, and so we're like, I don't think we can do this in a browser, and we're like, well, let's just try. And yeah, A-Frame allowed us to get something up and running really quickly, and then like iterate really quickly too. We were able to kind of just like prototype and try things. But so we've been working on this for a couple of years now, and so now we're really trying to focus on like, okay, how do we maintain this as like a long-term project? How do we make it really easy to reason about how our code works, be able to make changes, be able to fix bugs, like hopefully not have as many bugs. And so like I think one of the most important things becomes like just understanding what code is running and in what order. Like the execution order, I think is it's been one of the trickiest things to deal with um, with the way things work currently, because there's a lot of just incidental complexity in the way things work, because A-Frame tries to expose this this API that integrates really nicely with the web, and you can kind of think about 3D spaces as HTML documents, and you can interact with those documents in the way you might be used to doing as a web developer, like using query selectors and just manipulating DOM nodes. And though that's like a nice API for kind of transitioning from doing web development to experimenting with VR stuff, it adds like a lot of complexity, because now in the middle of you and 3JS, which is actually doing the work, there's this additional layer of browser APIs, and they have like some pretty complicated like life cycles. So like when you create an element, it's like a bit unclear, well, when is that code going to run, and when and it actually can even change on different browsers. So it makes like there's lots of like these weird race conditions and edge cases that happen in hubs where like when I create something, it's like really unclear what order stuff is going to happen in. And that's like that's a pretty tricky thing to deal with.
Yeah, you'll
Um,
see a lot of code in the Hub's client that's been written over the years that has something like, okay, this is the init method of an A-frame behavior. Check if we're in some good state to do
mhm.
initialization, and if we're not in that good state, postpone initialization till later. And then when we're running other parts of the frame, it's like, okay, if we haven't finished initializing this resource yet, then initialize it now, because now maybe it's safe to do. And then if anything depended on that thing's initialization, it's the same deal.
Yeah,
And
yeah, we have a lot of stuff like in tick functions. We'll have like a have I initialized yet, and we keep looping until we're like, okay, does this other entity that I need exist yet? And keep looping, like keep running my tick function every frame until the frame where that happens to be true. And then once that happens to be true, okay, start doing my actual work. Um, and yeah, that sort of code just gets really tricky to think about and to maintain. Um, and then the other pattern that's kind of common in how A-Frame likes to work, and this comes from the sort of webbiness background, is like events, event firing and receiving. So like in order for two components to communicate to each other, the way A-Frame components like to do that is by one component will fire an event, and then anything that wants to subscribe to that will listen for that event. But it makes it very hard to trace through when something is happening, like where is that, like what are all the things that are happening, and oftentimes even though we have this generic, like, okay, this thing will fire an event and then whatever wants to will listen to it, actually what we were really doing is like kind of encoding a function call through some extra steps. Like really what we wanted to do is like when this thing happens, run this other code. And we're going through this like layer of indirection to do it, and it makes it like more confusing to look at the code and actually understand what's going on. And that's not like an inherent thing in A-frame, but it's like a pattern that is common in the way A-framey things do, like to do things.
I can't remember a good example of this, but I feel like there are two different events also that is in the client code. One that bubbles up through the DOM node, so like only parent elements of the emitter can receive the event, or it's app wide, and that's more like anything that cared about it had a reference to the emitter and subscribed directly to that. And I think that second scenario has less. We had less difficulty thinking about those because anything that cared about it was there was an explicit like I need a reference to the thing emitting it, and I'm going to add an event listener to that thing. So like 3JS event emitters, I think, work that way where it's a little bit simpler. There's no bubbling. If you want an event on a 3JS object, then you subscribe to it.
Yeah, and events aren't inherently bad. I think that they're useful for certain kinds of things. For things where it truly is like, okay, there's lots of things that are just interested to know when something like this happens. I'm trying to think of some good examples. Like, I mean, when we reload the scene, or when you first enter a scene, there's lots of things that might care about that. Or like when I mean, when users join and leave, like that might be like there's examples of things where it's like, okay, I just want to like lots of things might be interested in it, and I as the thing creating the action, like the code handling the action, don't really know or care what else is interested in it. So like events are still useful, but I think we were kind of like overusing them in our code, and it's because it was kind of the prescribed way of communicating between components. But anyway, like there's like the point I'm trying to get across, I guess, is just like code execution order is like one of the things like we were really trying to wrangle and like trying to understand. Like we want to know when in a frame is something happening, or like when I create something, when is the code that's going to handle that going to happen. I think that's like the first few points here, and then like the other one of the other kind of major pitfalls we run into with A-frame is just by the nature of how it's implemented on top of 3JS, we end up with like a significant amount of additional objects in the scene graph. So for every A-frame entity you create, A-frame creates in 3JS a 3 group node to put all of the pieces, all the stuff A-frame components create kind of together in one spot. Because I can specify the position and rotation and scale of an A-frame entity, but then I can also add components to that introduce stuff to the scene graph. So I can add like a text component that puts some text into the scene, or I can add a positional audio component that puts a 3JS positional audio node into the scene. And so like one A-frame entity can actually represent multiple things in the scene graph. And so like the way A-frame does that is by actually creating another parent node that all of those new entities go into underneath. And that's like really useful for being able to like I said, have a single entity be able to do multiple things. And like the way you create behavior in A-frame is by creating components. And so like that's really the only way to expose or to add stuff into the scene graph. But what this ends up doing is a lot of our things only have one thing. So like, you might have an A-frame entity in the scene, and then, there's just a text node there, or you have an A-frame entity, and then there's just a box underneath it or something. But now we've like doubled the amount of entities that are in the scene. And it turns out like in 3JS, one of the more expensive parts of the work we do in a frame, and we've done like lots of work to kind of reduce this, but one of the more expensive parts is just updating the matrices for each object. So like once I've changed the position and rotation and scale of an object, every frame I have to calculate a new like world matrix for this object. And that calculation can be pretty expensive. in 3JS. And so
Yeah,
having
you also have to like project from the camera, right?
Mhm.
So even if the objects didn't move, you're still traversing the scene graph
Right, the
every
camera's
frame.
moving, and so having twice as many entities is like twice as much work to do. And so like we're paying this additional cost just by having A-frame as an abstraction here. And it's like so oh yeah, and then the last point here, just quickly, is like the network, our whole networking system is tied to A-frame as well. So moving off of A-frame also means kind of reimagining our networking system. But yeah.
There's an interesting example of something we had to do because of the introduction of the three
Mm,
groups, which is when we load a GLTF model that has an
yes.
animation, um, the animation track needs to get rewritten because it was it was loaded for the 3JS object that didn't have these group nodes introduced. So there's a section of loading that if you've ever seen, you're probably squinting at, and we're rewriting which nodes they're targeting. It'll target the parent instead of the actual node, or maybe it'll target the shop.
Yeah,
Actually, now forget how
like
it's
loading
working.
GLTFs actually just becomes like way more complicated, because like we want to be able to attach behavior to GLTF nodes. And so like if I have a simple a structure in a GLTF file with like, okay, there's a parent and a child, I have to insert A-frame nodes in between every one of those children, because if any one of them have components, they need an A-frame entity created for them. And that needs to introduce like an additional group node in between. So like we're actually like pulling apart the hierarchy, inserting a new group node in between each one, and then like that's a new hierarchy. And then if anything cared about the original hierarchy, which animations do, like animations are like, okay, the child of this thing is what I'm going to move. We actually have to like rewrite all the animations to be like not the child, but the child of the child. And the code is like it's really gnarly, and it's like I said, it's like not serving us anymore. Like I said, this abstraction is just kind of getting in the way. So we started kind of exploring new options. We're like, okay, we know what things we like about what we've been working with in A-frame. We know what things have been pain points to us, and so then we started to explore different options, and we played with different stuff for a while, but we've landed on something that we like. We like it. It's not a complete solution yet. We're not completely migrated over to it yet, and we're still like definitely not completely sure how it's all going to work, but we've kind of started to implement it. And yeah, it's important to like think about like for like what were the goals we were trying to achieve. So like I said, the most important goal is like we want to just make code easier to reason about. Like we want to know what order is stuff executing in. Like I want to know that when I create an entity, like I want to know when that happens. I don't want to have to like think about, okay, well, this is going to happen, and then maybe sometime later something else is going to happen, and I don't know exactly when. We want that to be very clear.
And
The
definitely it should not depend on what browser you're running in. If we want to
that
create a
yes,
box, like the box should exist right then.
exactly. Yeah, and like I said, like right now that's like not exactly true, and we actually still don't really like. I feel like I at some points in the history of working on hubs, I've like for brief moments understood entity execution order, but then it quickly fades away. Like it's so hard to keep in your head. But yeah, so like that's the most important thing. And then like I said, the getting rid of these additional nodes, like that's another big goal. It's like we want to get rid of them both for the performance reasons and like the simplicity reasons. Minimizing dynamic allocations and garbage collection. Like, so this is one of the things about running in the browser is JavaScript is a garbage collected language. And so whenever you create stuff, whatever it is, like you create some variable, you create some structure, the browser eventually has to, like the JavaScript engine eventually has to clean that up. And in order to do that, it kind of just has to wait until you're not using it anymore. And that last sentence I just said, like you're not using it anymore, is actually really hard to know. So there's things called garbage collectors that will go through and kind of like look at all the references to things and decide, oh, okay, like this is not being used anymore. What this ends up meaning though is if you create something and then don't use it for very long and then it goes away, like if you're creating lots of stuff every frame, you end up with John is showing this sawtooth pattern, which is, this is like exactly what you don't want to see in a JavaScript application. And unfortunately we have like the exact the stereotypical example of that in hubs. So what you're seeing here, that blue graph with the it's called sawtooth because it looks like a saw. Like that's like, okay, a bunch of memory is being used and then it's being garbage collected, and then a bunch of memory is being used and it's being garbage collected. And that means like every frame we're kind of like creating some stuff that's only living for a little bit and then it's kind of going away. And so one of the goals where we're trying to get to is to not be doing that. So what that mostly means is like, okay, whenever we're going to create stuff, like create it ahead of time, try to minimize the amount of stuff we're doing every frame to create like new things. So like, if we know that at some point we might need something, maybe it's like better to just like take care of it earlier on. And so that's what we do in our new the new entity system we have using bit-ecs. We pre-allocate everything, like all the component data that is going to live for the lifetime of the application. We just like at startup, we create it. And that means like we're using a bunch more memory than we were before, but it's like consistent memory. It's not this like this thing. And the problem with that sawtooth you see is every time that garbage collection has to happen, the browser actually has to pause execution of your code. So especially during major GCs. And it will like freeze your frame. Like you'll actually notice hitching. Like some frames will take longer because a garbage collection happened. And I think you can actually see it in the top part of the profile, or like where garbage collection happens, if you zoom in a bit. Yeah, so every time that happens, you like might drop a frame or might drop several frames if it's a big GC. So you want to avoid that to have smooth execution. Sorry, I'm just looking at chat really quick. Right, so minimizing garbage collection was another like major goal here. We haven't gotten very far on that goal, I would say, yet, just because there still is so much stuff that is not in this new system. So as you can see, like the thing John was showing, that's running on top of our new entity framework, but like the new entity stuff is only being used for a very small number of things right now. Oh yeah, so in the current hubs world, we have we define network prefabs. We have these like objects you can create that we need to be able to create on both ends. So this includes things like your avatar, for example. Like when I spawn an avatar, I need to create like a local copy of it, but also you need to see my avatar as well. The other thing, you know, the pen, anytime I spawn a 3D object or a video or an image, these are all these like the templates you're seeing there, like that. We need a way to be able to express this sort of thing, and kind of one way we thought to express it is maybe we should have if I want to spawn a pen or something, well, maybe this template should just be a gltf file, because we have a way to put components into gltf files. But gltf files are actually kind of a pain to edit by hand, and we like to be able to make changes to these templates. So we want to add new functionality to the pen or something. We want to be able to add components, and doing that by hand in a gltf file is not great. And so then you might think, well, we should just edit those templates in Blender. We put the pen template together and edit it in Blender, or the avatar template put together. Oh, like we want to modify the name tag or something, so just modify that's a glb file, so that's even worse. But what makes gltf files a pain to work with by hand is that everything is index based. And so like when you talk about like the scene graph, like if you go to the nodes section, the way you define children is like by index. And so like that first one, okay, that's saying the 0th index. So the child at index 1 is or the node at index 1 is my child. So if I want to introduce a node, like now all of the indexes are wrong. And so I need to, so editing these by hand is not a good idea. And so then you say, okay, well, maybe I'll just go edit them in Blender. What is annoying about that is then it makes it really hard to merge changes together. So if I say I'm working on some branch and I need to edit the avatar, and John's working on some other branch and needs to edit the avatar, and we both edit this blend file. Well, when it comes time to merge those branches together, the blend file is this big like binary blob, and it's like very unclear how you merge those together. So like it's important that whatever prefab system we come up with, system for spawning these networked objects, is like easy to version control, and then edit by hand. And so we'll show what we came up with, but like we came up with a JSX kind of text representation that mirrors the semantics of gltf, but maintains the kind of hand editability and version control thing we have from A-frame right now, like the HTML templates we have right now, but gives us like flexibility to not like we're not doing this like encoding from text and out of text. Like it's just we're doing it in JavaScript, and JSX, if you're familiar with React, allows us to do that in kind of a way that still looks like HTML, and like it's nice to make these hierarchical structures, but gives us the full power of JavaScript to do that. And then, like I said, because if we're migrating off A-frame, it means we're also migrating off of our current networking system. And we like the property of our current networking system that the backend is actually dumb. Like it doesn't do anything. Like in terms of moving these messages around. Like when I send my avatar position, I send it out. I send it to the Reticulum server, our backend service, and then all it does is just send it back out to everyone. It doesn't really need to know very much about what's in that message. It just knows that it needs to send it back out. And that's a nice property because it means that like our the cost on the back end is very light. And this comes from the kind of original prototype we had actually was like completely peer-to-peer, so there was no backend. And that's still theoretically possible to do. It falls apart pretty quickly once you have more than like 4 or 5 users or something in a room, because it means that for everything I need to send out, like I want to send out my avatar position or I want to send out my audio, I need to send that to every other user in the room. And so it quickly blows up. Like if I have 20 users in the room, everything I send, I have to also send to 20 people. And like I have to send 20 copies of my audio. And like that's a lot of outgoing bandwidth. So what we do is you just send one copy to the server, and then the server fans it out to everyone. But the server doesn't have to know very much to do that. And so we wanted to maintain that property. And then just another important property of this, the thing we're doing is like, well, realistically, we have to do this alongside of our existing stuff. We're not going to do this all at once. Like we can't just say, okay, we're going to rewrite the entire Hubs client and then ship it all at once. Like that's just not realistic. So whatever we come up with has to kind of happen alongside and kind of live in harmony with the existing stuff. And that's just also, even if we did decide, okay, we can ship this all at once, well, Hubs is about like being able to extend and customize. And so we can't expect third parties to also do that at the same time. So we're trying to do this in a way where we can kind of gradually transition pieces and still maintain support with the A-frame stuff we have, but start to migrate things piece by piece. So one second, I'm gonna get a drink.
I'm gonna peek at chat.
Yeah, that's not something we're doing yet, and that's definitely like a different different level of abstraction than we're talking. But like that is definitely something we want to have in the future. Like we definitely talked about. So if you've seen, and this is a sort of a side tangent, but like if you've seen, we have this like thing called fast room switching now, which was our first kind of exploration into how do we stitch multiple rooms or multiple spaces together. And that experiment you can easily see evolving into kind of more dynamically doing it, like having multiple rooms loaded at the same time, maybe, or like or smoothing the transition between rooms. So like right now we just like when you fast room switch, we fade everything out and then fade everything back into the new space. But you can imagine like if you create your environments just so like you could have like, okay, there's an environment here and there's an environment here that's meant to like go next to it, and like maybe I just preload that environment and like literally you can see it, and then when I walk into it I switch rooms, but like the geometry doesn't have to load. I just like now see a new set of avatars. There's lots of stuff we can do there. We've also talked about just like interest management type stuff where it's like maybe the room analogy even starts to fall apart, where it's like I'm not in one room. I'm just like subscribed to some number of people who are around me, and as I'm walking around, I'm starting to see different sets of people and hear different sets of people. That's like a whole ripe space for exploration. But it's kind of a different topic.
Yeah.
Right. So we talked about goals. So what are like the non-goals? Because that's kind of equally as important to coming up with a good design is like, what are we not trying to do? And I think the biggest difference we have in philosophy now from what like kind of a core A-frame philosophy is like, we're not trying to make it necessarily easy, air quotes, easy for people like without game development experience to get started. So like A-frame is like really good about hey, like if you just drop in these like 3 lines of code and make this thing that looks like HTML, you can like have a scene running, and you didn't even have to like put any code to make it so that you can walk around and look around in VR, and like you have hands, like all that stuff. Just like A-frame is very batteries included, and like one of the core goals is about making it as easy as possible to get started. Well, like I said, like we're in a different stage in Hub's evolution, and like that's not really our goal anymore. Like we don't want to make it hard on purpose or anything. It's not we're not trying to create barriers, but like we're optimizing for like I said,
Predictability.
Yeah,
So like
yeah.
an example of this is A-frame recovers from your mistakes for you. If you forget to add a light to your scene, they had for a while. I don't know if it's still the case with the
We
most
ripped it
recent
out,
thing.
but
They would say, "Oh, you're missing a light. You probably wanted a light, so we'll add a light to your scene." And this caused us some trouble when we said, okay, by default, there's no lights. We'll load it at runtime from the scene. If the scene describes some lights, then of course we'll add those lights. And scenes didn't look correct, and we were like, what the heck is going on? And we found this light, and we're like, where is this coming from? And so then we had to modify A-frame to say, no, like we really purposefully didn't want a light here. And that's the kind of thing where it's like, well, it did make it easier when we didn't know what we were doing. We had a scene, we forgot to add a light, and boom, a light was added for us. But it reduces the predictability of the code because it's doing something for you that you weren't expecting.
Right, and like another example of that is camera. Like if you don't insert a camera into the scene, well, obviously you wouldn't render anything, but A-frame inserts a camera for you. And actually, if you don't insert a camera, it inserts like a head tracked like VR camera that like I can, because like it's assuming that's what you wanted. But we had all sorts of problems where like we actually care a lot about that camera, and it's very hard to we care where that camera is and like where it is in the scene hierarchy, because we want to put it on your avatar, or on the viewing rig thing we have, which I'm not gonna get, but like that the execution order of that means that sometimes if our code happens to run fast enough or whatever, our camera will get created first. But if the A-frame code, or if our code's a little too slow or whatever, maybe the A-frame code will insert the camera, and then we have to like detect that happened and back out that camera. It got really messy, and like while that was useful for the goal of making it really easy to use, it's actually counterproductive for the kind of thing we're trying to do. And so like we're specifically not targeting that as a goal. Like we're actively trying to make things as simple as possible, even if it means that, well, if I didn't put a camera in the thing, I'm just going to see a black screen, and I'm going to have to be like, well, why am I seeing a black screen? It's because, well, you didn't tell it to render anything, so the computer didn't render anything. So we're trying to be as like direct as possible, and like I said, our target audience is people who, like ourselves, are like we're doing kind of deeper customizations. We can accept a learning curve, and it's like we're looking for a lower total ceiling. Like one of the things that happens with what we have right now is A-frame makes it really easy to get started, but then you very quickly will hit a wall where now I need to like I was saying, like now in addition to all the stuff I would have needed to understand anyway, I need to understand all that, but then I also need to understand this additional complexity that was inserted to make it easy to get started. And so we're aiming for the long term, right? So like we expect that the learning curve is actually going to be a bit steeper now. Like it's going to start off a bit higher. Like the there's a slightly larger barrier to entry, but we expect it to kind of be smoother. Like you're not going to like suddenly hit this wall where you're like, oh man, I need to understand 3JS and 3D math and all. Like that was kind of all a prerequisite, and like you just sort of took a shortcut and then hit the wall anyway, and it was a bigger wall. So we're also not trying to abstract away 3JS. Like 3JS is our core rendering library. It's at the center of everything. And so like one of the things we could have done is like, okay, let's think about this as a generic thing that renders 3D objects, and like the 3JS stuff is all tucked away in a box. We're not trying to do that. We say, okay, 3JS is like what we're using. We're not planning on switching to Babylon or anything right now. Like it's okay that a lot of our code looks like 3JS code and looks at 3JS objects. Like we expect that. So we in this new plan, we were not planning on trying to hide away 3JS. Yeah, like there's a note there. Like this might change as we start to like think about multi-threading and stuff in the future. But like for right now, 3JS is we expect that in order to work on hubs, you should know how to write 3JS code. And if you know how to write 3JS code, hopefully you should be able to work on hubs.
Cool. Maybe an example will help if folks don't know what we mean by like abstracting away 3JS.
Sure.
In 3JS, you've got these object transforms that live in object 3Ds. There's like, some temptation to say, okay, transforms are going to live together in memory in a bit-ecs struct, which we'll get to in a second. I'm getting a little ahead of ourselves. And the scene hierarchy is not going to be like parent-child relationships on each object. So that's also going to be represented in memory in like that same struct. And then we will at the last minute render like copy that data into 3JS objects just so that it renders correctly. But everything will be a flat 3JS scene, and the hierarchy will only exist in our application code. Like there's some potential benefits of doing that, but we run into the same struggle that we were describing with loading animations, where we rely heavily on the gltf loader that's been written and tested and works great for building the 3JS scene hierarchy. Mm-hmm. And we don't want to invite all of this complexity on ourselves for the sake of like, ECS purity or whatever you want to call it.
Right. And it also really butts into
we're perfectly happy right now using 3JS.
It really butts into like the working alongside of existing code thing. Like it would make it a lot harder to do that if we said like, well, okay, there's this like pure stuff that doesn't touch 3JS at all, like, or like it's completely abstracted away, and then like, but also it needs to live alongside all the A-frame stuff. Like that gets really hard to mix. So by kind of taking that trade-off, we accepted, okay, like 3JS is just part of the thing. I think it simplified a lot of things. So yeah, we've talked about a lot about the what and why and and why, but like let's actually start talking about like the interesting stuff. So so we're using this library called bit-ecs. We can jump into there. So bit-ecs is a pretty awesome library. It's like really tiny and has no dependencies. Like you can actually go into the code and like conceivably read it all, which is really important. And what it does is just it helps us manage state. It lets us. So if you're not familiar with ECS, it stands for Entity Component System. Very briefly, basically, components are just things that contain data. Like you can see there, like there's a position component, and that has an X, Y, and Z. There's a velocity component, also has an X, Y, and Z. Then you can create things called entities. Entities are just sets of, or entities can just have sets of components. Entities are just IDs, like they're just a number, and they just index into each of those component properties. The specifics aren't too important, but basically I create. So we already had this with A-frame as well, right? Like A-frame had entities and had components. This is a similar concept. The biggest difference here is that components in bit-ecs are just data. So like components don't have an init function. They don't have a tick function. So all behavior is expressed in systems, and bit-ecs actually doesn't even really have a concept of systems. They're just functions. But conceptually, a system is a function that you run every frame. And then typically systems are going to like grab some components and do something with them. They're going to modify them. They're going to look at them and do something else. And you do that through queries. So queries allow you to say, give me all the components, or give me all the entities that have a certain component. So this one you see there is like movement query. Give me all the components that have a position and a velocity component. And then this movement system, every frame, it takes the existing value of position for each entity, takes the velocity of each of those things, and just adds them on. So like this would create a thing that you give it a velocity, and then it's just going to move in that direction. And as you can see, the code is like very simple. It's just like data manipulation. It's just manipulating, and we'll look at like actual examples in hubs of what we're doing here. But basically, bit-ecs is just providing us this tiny little set of functionality to allow us to define components, allow us to define things called entities, create them, and associate data with them, and then process them every frame. Yeah, we can look at an example quickly. Yeah, let's look at our components we've defined. So in this branch, we decided to just try and rewrite the media frame and the camera system, or the camera tool system, not using A-frame entirely. So now if you go to hubs.mozilla.com and you look at a media frame, or you spawn the camera tool, those are now entirely created without using A-frame. So all of the stuff in the scene is just pure 3JS objects, and then all of the stuff actually doing the work is just bit-ecs components and systems operating on those components. So you'll see we have lots of components that just don't even have any data, that we kind of refer to these as tag components. They're just like a way for us to be able to say, like, well, give me all of the entities that have this. There's no data associated with them, but I can still query on them. And this is probably confusing if you've never worked in this sort of way before, but it'll hopefully start to make sense as we look at code. And I don't expect everything to make sense once. We're just kind of trying to do a high level overview here. But yeah, so the high level plan we started off with is okay. First, well, we have all these A-frame entities in the scene already. We're going to make those also bit-ecs entities. So now everything in hubs that was an A-frame entity is also now a bit-ecs entity. And we also started to do a thing where a lot of the A-frame components that we had before are also bit-ecs components. And what this allowed us to start to do is to, without having to break existing code or make radical changes, start writing things in terms of bit-ecs. So even if something is written in A-frame, we can start to like add functionality to it using bit-ecs. Trying to think of a good example we have in our code of this right now. But like the interaction system, for example, like the thing that lets you move the cursor around and whatnot, it works with both bit-ecs components, or bit-ecs entities, and A-frame entities. And again, all A-frame entities are also bit-ecs entities now. But like I can grab a A-frame entity, or I can grab a bit-ecs entity, and like it's the same grab component being used on both now. And so we were able to write all of this code for the interaction system as if we're just dealing with because we are dealing with just bit-ecs entities, but they are working on our A-frame entities as well. And so like this allows us to start to write the code that we want, even though not everything is in this new world. And like the abstraction leaks a little bit sometimes. Like sometimes we do have to say like, okay, if this is an A-frame entity, maybe do something slightly special. But we have an A entity component that you can check for, and you can say like, okay, is this entity an A-frame entity specifically, and then do some special code. But like it's pretty that hasn't come up that much, which is nice. So yeah, like I said, so new code we introduced to the code base, and this is mostly for like our internal stuff, but like you should start thinking about this in your custom clients as well. Once this PR lands in Hub's Cloud next month, and next month's release, so you'll start to be able to use this new API, and it's definitely going to be changing. Like we're like I said, we're still figuring this out, But I would start to explore this in your custom code. Like as you're starting to introduce new features, maybe think about trying to, rather than creating a bunch of A-frame components and writing behavior in that way, start to try and explore like, okay, what if I write this in terms of bit-ecs? How can I do that? So we're, for our internal code that we're writing, we're trying to now write any new code we introduce to the code base. We want to try and write in terms of bit-ecs. So even if it's operating on old on A-frame entities, we're going to try to write the code in terms of bit-ecs. And like I said, sometimes we'll have to look and be like, is this an A-frame entity to do something special? But that's how we're going to, going forward, write new code. Yeah, for networking, like we came up with this new networking system, and we might have, I'm just checking time. Yeah, we might have time to jump into the specifics of that, but like all new, completely not A-frame entities, like the camera tool right now, and like media frames, are networked using this new networking system. And then everything that is still using A-frame just continue uses networked A-frame. And like, there's two worlds that exist in networking now, and that's like not ideal, but like that's, we're not going to, for example, try to have A-frame entities networked over our new networking system or the other way around. Like these are just separate worlds. So yeah, like as we continue to do this, like we're going to gradually phase out A-frame. We'll probably keep A-frame like as a dependency, as like a thing you can use for quite a while, just because I think, custom clients are going to be using them for quite a while and whatnot.
Well,
But
this will be informed by like folks in the community telling us,
mhm.
as we're migrating, what problems you're facing, how we can help you, whether this is, whether there are chunks of A-frame that specifically we need to keep or keep the whole thing. And also the reason that we're going to start doing these streams is to help people understand this transition.
Mhm. And yeah, like I said, it's going to be a while till like even all of the internal code is changed. So far what we've done, like I said, is media frames and the camera tool, but like that still leaves, and yeah, to the next point, like we're not trying to just like one for one replace everything. Like this is again mostly for internal, but also if you want to contribute, like the goal is not to look at each A-frame component we have and say, okay, we have the super spawner component, let's make super spawner bit-ecs component. Like that's at the wrong level. What we should do is use this as an opportunity to think like, okay, like what is the problem we're trying to solve? Okay, we want to have things called spawners where you can grab objects and move them around. That's the problem we're trying to solve. The specifics of how it was implemented in A-frame are actually like probably a trick, because this is just a different way of thinking. So like you shouldn't go in with okay, take each of the components I had before, make the new components, and then write some new code. It's like tackle the problem from first principles again. And oftentimes you'll end up at like actually a simpler solution. Like we definitely found this as we're doing things. It's like a lot of the things we were doing maybe was like incidental complexity, or was just because of the way we were we had framed the problem, and maybe those go away once you simplify things. And so we're taking it upon ourselves as we're migrating new things to really use this as an opportunity to like clean stuff up, to rethink, is this a feature we even need? Is this specific sub parts of this feature things we actually need? Is this actually what we want anymore? And so it's a
As
great
well as
opportunity.
asking for ourselves, okay, like if we're a third-party developer and the client didn't have this feature,
Mm-hmm.
what would we need to do in order to add this feature so that we have like a better story around supporting add-ons or extensions instead of fully custom clients,
Mm-hmm.
or
Mm-hmm.
in addition to fully custom.
Yeah, we're definitely, this is like a longer term thing, but it's something we're heavily thinking about. Is like we want to have the ability to say, like, have plugins or something, right? Like right now the customization of hubs is like this all or nothing thing, where it's like, there's lots of people out there who have these custom clients, but it's very hard to share those changes with each other, because it's like they're not compartmentalized at all. You created a fully custom client, like Paradowski has like a bunch of awesome stuff in their client for like dynamically loading parts of environments and spatial triggers and all this really cool stuff that they've showed off if you've checked out their stuff. But there's not really a good way for them to share, like, okay, like I just want to share the part of functionality that is like spatial triggers. Like I just want you to be able to like walk to this spot and trigger an animation or something. Like they have a cool system for that, but there's no way for them to say bundle that up and say like, okay, if you want to install this on your Hubs cloud instance or your upcoming like hosted Hubs thing, there's no way for like them to do that. But we want to have something like just plugins, like similar to how you can do with WordPress or other things, where I can just install that bit of functionality on my server. And so we're definitely thinking a lot about that as we're doing this transition and as we're kind of creating this new framework. Like, what is it going to look like to create plugins with this stuff? Yeah, so this will be in next month's Hubs cloud release. This PR will land. And so, I mean, you can start right now if you pull the master branch and start building on top of that. You can start right away. But it'll kind of be in the kind of default shipped Hubs cloud. That'll be part of next month's release. So we've already cut the release, and it's we started the QA process for next month. We do that right after we ship the previous month. So this will be in next month's release. But you can start experimenting, like I said, pull down the master branch and start playing with it right now.
Looks like there's another question about anything changing spoke side. Not immediately. Luckily, the interface between Spoke and Hubs is Spoke generates this GLTF file, and so there's like a well-defined interface for getting components that were added from Spoke or Blender through the Blender add-on and Blender exporter into Hubs, and so over time, what might change is the way Hubs looks at GLTF files. Maybe previously it would see the Hubs component in the GLTF file, create some A-frame components and behaviors. Some of those might transition to, instead we're going to like add this data to the bit-ecs world as component data, and some system is going to update every frame or whenever it's appropriate.
Yeah, and we actually do data.
This. But spoke scenes that are already created shouldn't be deprecated by this, and I can't think of any components that are at risk for being deprecated because of this change.
Yeah, not because of this change. I mean, like we might decide that some components are something we don't want to support anymore, but like this design doesn't inherently change that part at all. It actually like it fits hand in hand, because like we'll get into, like the template things we created are actually semantically, we want them to be equivalent to a GLTF file, which means they're equivalent to whatever the Blender exporter or Spoke spits out. And we've actually by moving media frames over to this new system, we've actually already done a thing where you create a media frame in the Blender exporter or in Spoke, and right now you bring that into Hubs, and that uses the new stuff. Instead of creating an A-frame entity for that media frame, it creates a bit-ecs entity, and like there's no media frame A-frame component anymore. It's a bit-ecs component. The way it's tied in right now is like a little bit weird because we haven't done all of GLTF yet. It's just media frames, and so we do like a little bit weird thing where like the media frame node you have in the GLTF file actually is an A-frame entity, and then we stick a bit-ecs entity underneath that. It's like slightly weird, but I can see the path to how we'll basically do it, and yeah, it shouldn't change the external interface at all. Cool.
Okay.
Right. So we talked about this, like properties in bit-ecs are all just data, and they're actually all just numbers. So this goes back to like the goal we have of trying to reduce allocation. So in bit-ecs, when I define a component, each of those properties, what we're doing is we're saying for all of the data we might create for that property. So yeah, if we look at one of these components, like for each of these properties, you can see they have a data type, and we're actually at the start of the application, we're going to allocate a typed array, this is like a nice linear in computer memory array of data with a fixed size, and we're going to allocate that all at the start of the application. So I think we pre-allocate for 10,000 entities right now, which is actually like pretty significantly over allocated from what we've typically seen in hub scenes. Like you'll see even during like the meetups that we have on Fridays where, we'll have like 15, 20 people or something sometimes, we don't get above like 1,000 entities or something. And so we're pre-allocating for like 10,000, which is, wasting some memory, but it means that as soon as the application starts, we create all this stuff, and then we don't have to ever garbage collect that or worry about the cost of creating it or anything. It's all pre-allocated. It does mean though that because these are in typed arrays, we only have these primitive data types. We only have numbers. And that seems restrictive, but it actually hasn't been too bad. And because entities are just numbers, you can easily just associate additional data that you need by that entity ID. So like if you, and we do this actually with the EID to OBJ thing. So like when we want to associate an object 3D, like a 3JS object with an entity, we just have this big map from entity ID to object 3D. And like it's very simple to work with. And so like you can do that in your own code as well. Like if you have some more complex data structure that you want to associate with an entity, like you don't have to feel like everything has to be crammed into a component. You can just use a tag component like we have for object 3Ds. We have an object 3D tag component. So let's just say like, give me all of the object 3Ds. I can still query for them, but like the actual data is this complex data structure. And so we just store it in a map, and it's not like the object 3D tag component doesn't have any data. So yeah, bit-ecs components themselves can only have numbers. But like that restriction actually, as we were rewriting some stuff, helped us simplify things. So like for media frames, for example, the previous media frames, had a type, right? So which type of media does this media frame accept? It can accept all media, or only 2D media, or only 3D media, or PDFs, right? Previously we had these as strings because I don't know, we just didn't think very hard. We're just like, okay, like I want some types, and so the type is all, or is 3D, or is only 2D. We had these different things, but like because we were kind of forced to rethink the problem about, oh, we want to store this as a number. How do we do that? Well, we came to like the better solution of, well, these should just be bit flags that I can compare together. So I can say like, oh, I want just PDFs and 3D models. Like we can do that now. We couldn't even express that before, but you can now. And it's actually like, it made the code simpler too. So while this like component properties can only be numbers thing feels like a restriction, I think it actually helps you possibly reframe the problem and land at better solutions, and certainly goes towards our goal of minimizing allocations. I think we covered that one. Okay, so we should talk about this JSX thing we came up with. So like we were talking about before, we want to be able to define these prefab entities that we want to be able to spawn on both sides. So yeah, this cube one's a cool example. So if the part of this branch is we ship this little secret command /cube, you can type into hubs on hubs.mozilla.com now, and it'll spawn a little cube that is physics enabled and has a media frame in it. And so this is all using the new code. So that has no A-frame entity associated with it. It's just the bit-ecs entity. And it has a couple components on it that add that behavior, right? It has a rigid body component that lets it, respond to physics. It has various components that let you grab it with both the cursor and your hands in VR. And then on top of it, it has a media frame that you can put objects into. So if you spawn a duck, you'll see that that thing has, you can just make another cube too. You'll see that thing has a media frame on top of it that you can drop the duck into. And then like we actually gained the new feature sort of for free because of just as we were rewriting it, it just kind of naturally came along. Media frames are movable now, and they'll move with the media that's in them. We also fixed, like, again, just kind of naturally falling out of it, a number of bugs that existed with media frames where, like, if you had two media frames next to each other, where an object was touching multiple media frames, it might jump around a bunch. Like that all became a lot easier to reason about as we were writing the new code, because it's very, like, you just think about it as this like data transformation. You're like, okay, I have these things, like it's very easy to like look at all the media frames and decide, okay, like what am I going to do? So oh yeah, so I was like, what were we talking about? Yeah, so so this is the template for that cube. And so you'll see this looks a lot like HTML, but it's actually using JSX, which if again, if you're familiar with React, is this thing that allows you to write these hierarchical structures in the middle of your JavaScript code that kind of look like HTML, but just compiled down to JavaScript functions. So like before this ever hits your browser, this just becomes a bunch of function calls to this create element entity function. So you don't really need to understand the specifics here necessarily, but like that gets converted into a bunch of function calls. And so we're not doing like text parsing at runtime or anything. Like these properties, like as you can see, we can just assign like that object 3D. We're just assigning that 3JS object into that property. Like we don't have to do any sort of like conversion from text into numbers to like the way we're doing those physics shape. Like we just have an array in there. It looks very similar to how we do it in A-frame, but in A-frame there's all this like code that's running at runtime to do the parsing. So like we'll take the string of 0.5 comma 0.5 comma 0.5, and then we'll like parse that into an array of number. Like that's all happening at runtime with our A-frame code. With this, it's already JavaScript, and like the JSX structure you're seeing is just handled at compile time, and that's converted to just some function calls. The important bit though is that like we're still able to have this sort of expressive, nice to manually edit and nice to version control way to express these network template objects, but with all the benefits of being able to write in JavaScript and whatnot. And so you can see each of those entity tags is a bit-ecs entity, and then each of those properties on that tag, there's a couple special properties like name and position and scale and visible that just apply directly to the object 3D. But then the rest of those are just components, and we have a set of inflators, we call them, that take that component data that comes that you're giving it. And this by the way will be the same interface that gltfs will use. So like the inflator that you see here for media frames is like, okay, that's also what a gltf will use to create a media frame. And so that it's the same interface. But so each of those calls some inflator function that takes that component data and turns it into bit-ecs components, and also maybe turns it into some 3JS objects. So like if we look at the media frame one is good. It has some properties. Is that I'm trying to think which one we should look at.
This one's going to be a little complicated because when you
Yeah.
create a media frame, it creates a shader.
Right,
and,
right. What about the text one? I think that one might be simple.
Sure.
So yeah, so this is the text inflator, the text component inflator. And so you give it some properties. And so we use this on the camera tool. The new camera tool has some buttons with text. Oh, and by the way, you'll see like we were able to create like a button as a thing. We have sort of some of this functionality in A-frame with like through mix-ins, but they're really confusing and hard to work with. Here, because we're just using JSX, we can also create custom components that are just some more entities and some more data, and then like we're able to use those to define that whole the camera menu, and like that reads really nicely. Like we can actually create these things that are composable. So we can make this button, and you can use this in your code as well. And then we can modify how a button works, but all of your code still continues to work. So yeah, as you can see, there's the text component there, and that has some properties, and then those properties get passed into the inflator as the component properties. We have some default values we apply, but then we just actually create like the 3JS stuff we needed. So like we have that text thing from Troika 3 text, which is the same text we're using in Hubs right now, but like this is just 3JS code here. Like you just create the object and do whatever you want to do with it. Like this isn't Hub specific or special or even bit-ecs specific. But then what we do is then we have this function called add object 3D component, which you give it an object 3D, any object 3D, in this case the text, and it just manages that mapping I was talking about before for you. So it adds this object 3D tag and then sticks it into this map. And then if we're in some system and we want to like do something to the text, so if we look at the camera tool system, this modifies it. And I know we're jumping around a lot, and this is a lot to take in, so I don't expect this all to make sense right away. But hopefully,
I'm guessing when we update the UI of the camera, this is
right.
what you want to see, the
Right, exactly. So
the
we were able
text
to
of this object, or the
right, and
countdown
so
object.
that countdown label object, you see where we get the reference to that. We just pull that out of that world.eid to obj map by entity ID. So we have like we have like the camera tool component has a bunch of references to all of its labels, and so we do this ref thing, which again, if you're familiar with React, is like the same kind of concept there. We create a ref, and then we can have the camera tool point at that label, and then using that, like that just that will be the camera tools label ref property will be the entity ID of that other entity, like the label entity. And then I just pull that out of that map to get the actual object 3D. So like that variable right there is the Troika text object 3D. And then I can just do with it whatever I want. Like I'm writing normal 3JS code. And so we update the text and then we sync it. And that's just that's how you would use that component in any other 3JS application, or that object 3D in any other 3JS application. From entity initialization to being visible, interactable with a scene graph, do you know what the baseline performance increase is going to be for me? Specifics, I'm not sure, but there's basically nothing going on now when I create an entity. That JSX like templating code or whatever, that render stuff, that might take some time or whatever, but like there's so much less going on that like it's essentially impossible that it'll be slower. I would say performance was not like our key, like that wasn't a key goal, but I think it's going to be a nice benefit. Like the more important thing about that is like I know that when I create the entity, it'll exist right away. And there's no ambiguity about like when that'll be in the scene graph, and that's like really the property I wanted. So like as soon as I create that thing, it exists. The object 3D is going to exist. The components are on it, and then when a system runs and it says, "Give me all the object 3Ds" or "Give me all the text labels" or whatever, like I can immediately start using those, and I know that they're there.
Okay.
Yeah. So hopefully that JSX stuff will just lead to being able to create up kind of this library of components that we can then compose stuff like that cube thing. I just quickly wanted to just try it. I was like, okay, like let me just make a cube and then like I'll stick a media frame on it. Like I was really quickly able to just like make that thing, and it didn't require any additional like code or anything to do. And like the way our new networking system works, and I don't know if we want to get into the specific details of that, but like it didn't even require me to say anything new about it, because now rather than like having these like well, I mean, I had to define a new prefab, but like the networking of the data is at a component level now instead of like at in the current system they're called schemas, so it's not like at a schema level anymore. So like there's not a network schema for cube, but rather there's a like network schema for a network transform, or there's a network schema for a networked media frame, which is like the data about a media frame. But if I just want to create another object whose position is networked, I don't need to create a new schema because network transform is what is being networked. and yeah, you'll see like we add that to the camera tool, and we add that to that cube prefab. And so they're both just using that same networked component. But yeah, the networking system is probably something we'll cover separately. That might, well, I don't know. We'll see where we get. But that's a whole nother thing. Trying to think what else to cover. So yeah, I mean, just I guess very briefly to talk on the networking system. So like it's not very different from networked A-frame in terms of semantics. Like we still have the concept of, and if you're, it's very likely you don't even know how how this works unless you really dug into the hubs code. But there's a concept of ownership with objects and hubs. So like if I create a duck, I tell you to create that duck on your end, and so you create it. But I'm the owner of that duck. And what it means to be the owner of something is you're the one who's responsible for updating the properties for that thing. And so as I'm moving around the duck, I'm sending out the new positions of the duck, and everyone knows that I'm the owner of the duck. And so they're going to listen to my positions. So if you start sending positions of the duck, no one's going to listen to you because you're not the owner of the duck. And this is not like a security thing. It's like a synchronization thing. So then when you grab, like someone else grabs the duck, at the same time they grab it, they also declare that they are the owner of the duck at a certain time. And so then now they're the owner of the duck. And so like they're moving the duck around, and now we start listening to their opinion about where the duck is. And so anyway, the ownership model has not changed. We kept that the same. We did simplify some things and make some things more explicit. So like in networked A-frame, and sorry, this is like really getting into the weeds of the details, but like in networked A-frame, when you create an entity, like there's no like create message in networked A-frame. There's just like well, this object exists and here's information about it. And if you didn't know about it, and it's a full message or something, then you should create it. In our new networking system, this is like much more of an explicit action. There are create messages for objects. So you say like, okay, I want to create this object. Mainly it simplifies things and it removes some bugs. And it especially simplifies, there's some weird stuff. So the way networked objects that exist in the scene or in a GLTF file work in hubs previously, or work in hubs today, I guess, for non-new objects, is like this kind of really weird behavior. It's not really well defined, and we only really made it work for scenes. So you can have media frames in, like previous to the change, you could have media frames in scene files, like in your environment. And that would work because we sort of treated the scene as a special thing. It was like, okay, that media frame is owned by the scene. And we baked a network ID for that thing into the GLTF file. And so like, it's like, okay, we know what that thing is ahead of time. But like, if you tried to just drag some GLTF files previously into hubs, and they had a media frame in there or something, you would see some really weird behavior. Like it would kind of work, but what you ended up with is you actually had two media frames that had the same network ID, but like could have different owners and stuff. And so you would see like really weird behavior happen. In the new system, that all that ambiguity is gone, because like every creating objects is a specific message. And like we also came up with a scheme for like defining IDs for things based on their position in a GLTF hierarchy, for example, or their position relative to other network objects. So you can have things that exist in a scene or in a GLTF and still be networked without like having that weird ambiguity and odd behavior. And that's something we were trying to do, because like we want you to be able to create GLTF files that have all sorts of dynamic behavior. We want you to be able to create an asset that has a media frame in it. You want to create an avatar that has a media frame in it, or like a GLTF that has a waypoint in it that you can sit in or something. It's a car, like we want that.
Chessboard. There
Yeah.
was like there was that chessboard, that movable media frame pull request done by, I forget.
I think Pellinor did that one.
By Ronsley,
Yeah.
where like it was really cool, and they, he built it for his Hubs Cloud instance. So like this model was loaded, and then he could like pull the pieces out, and we ended up not merging this for. And it was painful not to merge it because there was a lot of work that put into it. But this was something that we like referred back to regularly when thinking about the networking stuff. It's like, okay, that you should absolutely be able to put this thing in your scene or load it at runtime and like independently network the position of all these objects in a deterministic way.
Right. And this is something we should totally be able to support now with the new networking system. Should allow you to bring in a file, and then each of those chess pieces or each of that those parts of that engine would all have network transforms, and so like they would individually be networking their own positions. It doesn't have to just be that root object that has a network schema, and like you don't have to try to create a new network schema for a chessboard. It's just, well, the chessboard happens to have things that that are networkable. And this is another example, he had done some kind of painful work here to make these media frames that are close to each other not behave so poorly. And that was another thing, like when we were re-implementing media frames, we're like, we want to make sure that that just works. And in the new system, we didn't have to do like weird hacks to make it work. It just kind of worked. So even though we didn't merge this, it was like still a very useful reference as we were implementing new things for the kinds of things that we want to do. And so like that's a good thing to touch on. Like we're not always going to merge PRs. So like a lot of times people will do some work for their own Hubs Cloud instance and they want to contribute it back. And it feels really painful to like not merge those things sometimes, but know that they are still useful both to us and just other people in the community, right? Like if someone else wanted to implement something like that, that code is out there and they can look at it and they can learn from it, or they can literally pull it and use it. Like we try to keep like the Hubs core pretty lean and pretty minimal as much as we can, just because we don't want to have to maintain it all forever. Like every time we make an update, everything we add into the code base is additional maintenance burden. But this is like also the kind of thing that once we have plugins, it's like it'll be a lot easier to say like, okay, no, this doesn't belong in the Hub's core code base, but like this would make a great plugin, and then people can benefit from it. But even when we don't merge stuff, like we do look at it and we do learn from it a lot, and it influences the future of the product. So I don't want to discourage people when they make something like this and then it doesn't get merged. It's like we still really do appreciate it.
Yep. So to clarify, the network schema has effectively gone down a level, simplifying the creation of prefabs and custom objects. Yes, that's correct. So the network schemas used to operate like, for every type of thing you want to network, you need to create one of these schemas. So like an interactable media, it has position, rotation, and scale, updated it, that has some synchronized state, has a media loader. And interestingly, it also if it had a media video on it, then you would get the time property synced. And if it had media PDF, which, these two would never happen at the same time, then you would sync the index or the page that the PDF was pointing to. And now instead of this, this leads to like this difficulty of like, well, I want one of these, but I want to add like one component to it. Well, now you need to get that schema into the
and you'll see we have this,
schemas.
right? Like we don't just have interactable media, we have like interactable media and like static controlled media and like
static media,
static media. So
media,
like, and these are all like really just like remixes of the same thing with just like slightly different things. And then we have a separate template for each of those things in hub.html. Like each of these things is also a template for like, okay, what actual entities and components do we want to create? So by having the like I said, moving it down a layer, we're saying, okay, how do I network this component, like this specific thing? And it also in networked A-frame, there's not a concept of like, and this is not really like a hard limit, I guess. This is more just like how things were done. The kind of idea behind networked A-frame is like, okay, you should be able to take an A-frame component that has no idea about networking and then just start networking its properties. And so I can operate on it as if it was like a local thing, and then just those changes are mirrored across the network. And so you can still do that with this new system. Like there's nothing special about the networked transform component or the networked media frame component. But it turned out to be easier for like media frames, for example, not to try and network the media frame component, but to have a concept of like, this is the networked state of a media frame. And so then in the media frame system, what we can do when we're trying to resolve things is we say like, okay, what's the latest network state we got about the media frame, and what's our current state, and we can compare those things and then like do the right thing. So it's like, oh, if my media frame is like empty and the network state is telling me that it's like supposed to be holding an object or something, well then I have to do the stuff appropriate for that for that state transition. And so like that's not required, like that they be separate, but so so far the things we've implemented, it's been more convenient to make them separate objects so we can think about them in a separate way. And yeah, as John showed there, the schema is actually just an object with a serialize and deserialize function. We've created a this define network schema thing that will take a bit-ecs entity, and because these are nicely typed, we can just generate a serializer for it. But you can do this yourself. And this is very ripe for change. Like the actual encoding format is still really ugly. We're still using JSON objects just because we actually are still sending this data over the networked A-frame WebSocket just to ease to make it so that we don't have to make backend changes to deploy this yet. But this is definitely going to become some sort of binary encoding, and so the specifics of the serializer and deserializer are definitely going to change. But yeah, you can write these yourself too. So if you had some like very specific logic you wanted to do about a network component, and like you really want to just give me the buffer to write into, and like I'll read out from it on the other side, and like just do whatever you want with it, you can do that. But then we made this like define serializer thing, which is actually kind of intelligent. It will only send properties that have changed. Like it'll look at like what it sent last and only send properties that have changed. And the deserializer on the other end knows how to do that too. It's like, okay, like I'm going to get these partial updates of like, okay, only the X value has changed and not the Y and Z value. So I'm only going to update that. So the default serializer will do that for you, but you can always override it with your own custom serializer. And yeah, like I said, like the specifics there are definitely open to change, but we're pretty happy with where it's landing. And what's cool too is like the entire networking library that we've written is like not very big, and it maintains almost all of the functionality of networked A-frame, and like there's really not very much to it. There's this network send system and there's network receive system, and so just like every frame, we decide here's all the stuff we want to send out, and then when messages come in, we queue them all up, and then we process everything since the last frame that needs processing. And yeah, I think it's like a couple hundred lines of code, I think, and it's pretty reasonable.
We could probably do the send system, just walk through it, and you can imagine what the receive side looks like.
Sure.
So like at the end of every game loop, the tick function, we do this network send system. We send it the bit-ecs world. We don't send every frame. That would be quite a lot of data. So we say, okay, we'll send 12 times a second. So the first thing we do is like usually don't do anything. But once it's time to send data, anyone who has joined the room since you last checked needs the full state of data that you of objects you own. And so we say, all right, if anyone has joined, create a message for them that they're going to need, and well, networked objects query will return all the objects that are networked, filter it by the ones that I created, send updates for any objects that I own. Don't send any deletes, I guess. Oh, right, because like when somebody joins, you're not telling them, okay, I'm deleting something. Mm-hmm. So for every client that joined, you just say, okay, send that message to them. Get their client ID and send it to them. That handles late joiners, anyone who comes in. And then for everybody else, this is the more regular case. If you created any networked objects, if you deleted any networked objects, or if you own any network objects, you need to send create messages, delete messages, and update messages for them. And we broadcast that rather than send it to a particular client. We just broadcast that to everyone. And so like the send message is all well, like, you know, some amount of complexity is buried in this message for function, but there's really not a lot.
Yeah, most of
These
it's just all about like, you know, you like collect all the things you're looking like. Most of it's like look at a query of some amount of entities, gather the data you need about them, and then pack them all together. And like I said, like this actual structure we're using, this JSON object with these arrays and all that, that will definitely change because it's very noisy. It's not quite as noisy as as what we have now, I think, but it's still pretty inefficient. Like the most funny and sad, funny, inefficient part about what we have right now, and like what this does too, is because we're encoding it as text. If you have a number, which we have a lot of, you know, like a position, you have 5 point, you know, whatever. Yeah. So like that number, we've taken a thing that we can represent in a 32-bit floating value, and we've expanded it so that every character is like we've made it way more bits, right? Because each character, at the very least, is 8 bits, but maybe it's like Unicode. I don't even know how it gets encoded. So like we've made it much bigger, and so it's like more data we're sending, more data we're processing. So that's very inefficient, but like we know how to fix this, and we're going to fix that. And it shouldn't change any of the rest of the code. Like this is very much a specific to the networking system implementation detail. That's a side tangent.
Yeah. So that's basically. I mean, I'm skipping over some of this stuff.
We can look at the network transform system really quick, because that's like a cool example of like how do you actually like write the code to handle networking. So like the synchronization of that networked state across the network will happen for you by the networking system. So you just tell it like, what is the thing you want to synchronize, and it'll say like, okay, whoever's the owner will synchronize that data, and whoever is receivers will just like have that data overwritten. But then we have, for network transforms, we have like a very basic system written. This doesn't do any of like the nice like lerping and interpolation and stuff that the current, like when you move a duck around or something right now in hubs, using the old networking system, it's even though we're only updating at 12 FPS, it like looks smooth on your end. We're not doing that yet in the new system. So you'll notice now if you move a camera around in hubs, other people's cameras will be a little bit jittery. Like you won't see it for your own camera, but for other people's cameras, you'll see it'll be a little bit jumpy. I don't know if that'll come across in the Zoom, but we can try.
That's a good point.
It might even, but like, but yeah, it's only updating at 12 FPS, so it won't look smooth. But like, because we haven't implemented that yet, the code is really simple.
It's very simple.
So
this runs early in the frame after we receive network updates. We run this network transform system, and Dom, you want to walk us through it?
Sure. So yeah, basically we decide the first thing to know is like, am I the owner of this thing or not? Because if I'm the owner, it's my responsibility to update this network transform object. If I'm not the owner, it's my responsibility to take the latest network transform object and apply it. And so the code is very straightforward. Like all we do is, if I'm the owner, we'll take the object's position or rotation or scale, and then we do some like sort of optimization to not send as frequently. Because like if things are like have only moved slightly, maybe we don't really care about networking with that level of precision. So we just say like, okay, only update it if it's not near the old position. But yeah, then I just assign that property to the component for that entity, and that's it. Like then the networking system takes care of every frame, saying, or every network tick, 12 times a second, sending out the latest state of the network of the networked object we have. And then if I'm not the owner, it's very similar. I just take the latest network state and I I just copy it onto my object's position, rotation, or scale. And then we have in our 3JS implementation, we have this thing where when you modify a position, rotation, or scale, you need to set this flag. This goes back to that thing I was talking about where matrix updates are expensive. So we only do them when you set that flag. And there was a question in chat about like the like supporting code suggestions and whatnot. Like that actually works really well. A bit-ecs has TypeScript definitions for all of its functions, but also like the custom components you create. There's a TypeScript definition in bit-ecs for that as well. And so like you'll get like code completion. We'll see if John's editor works correctly. Yeah, okay. That's but you'll see that like those give you type completions for each of the components. We don't have any sort of completion yet for like the JSX stuff, but I suspect it should be possible for us to do that somehow. I haven't really looked into it, but I suspect there'll be a way for us to kind of define like what components have inflators and then like what the properties of those inflators are. If anyone's like a JSX kind of expert, maybe you know how to do that, but I haven't looked into that yet. But yeah, the type the editor support for this is definitely much better than it was in A-frame, because it's just JavaScript, right? It's not, we're not doing this like runtime evaluation of HTML to create these things. It's just like, nope, these are just like all of the components are just JavaScript properties. You import them, like you see like at the top there, like that owned component and that network transform component, we just import those. And also all of the values you're setting are just arrays on that thing. So like network transform.position, that's just an array that you index by entity ID that has the position arrays for that component.
Yeah, and you said this, but in case this isn't clear, because maybe this isn't how you're used to seeing this stuff updating, in the top half when you're owning it, this to array is saying take this object's position and write it into this, the section of this position array. So this is writing to the network transform component.
That syntax is slightly confusing. Like you could have written that as like network transform.position.eid 0 equals object.position 0 or .x.
Yeah.
Mm-hmm. Yeah, so like I said, the current implementation is still actually going over the networked A-frame WebSocket. So the actual network part hasn't changed too much, and we're still using, because we're still going over that WebSocket, and that's like not a binary WebSocket, we're still using text encoding and still encoding JSON. So like the amount of network data that's going, like the amount of data that's going over the network for this new networking stuff currently is pretty similar, pretty comparable. But like we plan to, and we should be able to make it much more much less network data. Whether that'll like change the amount of like use, like I think the question's also asking about like number of users in the room and whatnot. Like really that's like not our bottleneck right now, I would say, for number of users in the room. Like it, like avatar transforms is not really the bottleneck. It certainly doesn't help because it's very noisy right now. And so that will reduce it. But like we have other bottlenecks, like just, and maybe a lot of this work overall, like just improving client performance overall will help, because I would say the biggest bottlenecks are just the performance of the client on each person's system, and then there's definitely quite a bottleneck in just WebRTC stuff. So the number of like audio streams we can have. There's like kind of hard browser limits on how many you can have, but then also just like that's a lot of networking too, and that gets solved more by like the sort of interest management stuff I was talking about before, where like rather than subscribing to 1,000 audio streams, instead I just like, as I'm moving around, I dynamically switch which 16 audio streams I'm listening to, and I think that's how we get to high user counts. But like certainly every little bit will help, and optimize.
That's what I want to emphasize, that I think that right now our client is suffering from like death by 1,000 paper cuts type of performance issues, and so like I do expect over time for us to see hopefully much better performance. But yeah, you're right in saying that like WebRTC audio decoding, I guess, is that what the main work is doing?
Yeah, I don't know the specifics, but I know like literally just having lots of WebRTC connections, like there are just limits to the number of WebRTC
Hmm.
connections I can have. But then yeah, like audio, like the panner nodes, like the positional audio stuff, those can be expensive. We've already like explored ways to make that cheaper too, like just using a slightly less
Mhm.
good panning model. And
Rendering will continue to be expensive until we do level of detail or
and like instancing, like for avatars, for example, like if you want to have 1,000 avatars in a room, you can't have 1,000 uh completely customized, fully articulated, like they all have media frames, whatever, like avatars that are like really complicated. You might, yeah, you might do like level of detail, you might do some amount of instancing. I've seen some awesome work happening in that actually. There was a pretty cool tweet from, I believe it was the Webverse people. They have like the instancing of their avatars almost working, which looks really cool. Like they're actually doing like the sort of dynamic batching stuff we experimented with objects. They've done it with avatars. The tweet is
Hmm.
pretty funny because it's a cool bug, but but yeah, like that's certainly um something we'd like to get to, right? I don't know how many users we're targeting or whatever, but like that's a constant request we get. It's like, well, we want more users in the room. So it's about trade-offs.
Will there be any way to get a message from a non-owning client back to the owner of an object, for example, a network door that anybody can click on to open it? This is currently very awkward in NAF. Um,
I think about
let's
that. So
see. In the receive system, I think we by default ignore messages from people who are not the owner because
mhm.
we expect that to happen a lot. Like as ownership transfers, the person who lost ownership won't notice right away, so they'll like send another update or something. Um, but it it wouldn't, I don't think, be difficult to support that where like
But
maybe
I
there's
think
a special flag on it or it's an unowned object or it's something like that.
but I think you can also take ownership of the object, right? Like when you click on the network door, well, you clicked it, and in order to update it, you should take ownership of it. And um, ownership transfer, both in NAF and in our new model, is not like a two-way process. You just declare yourself the owner, and then everyone listens because we've agreed on the rules of ownership, and the rules of ownership are pretty simple. It's just that like if the time you declared that you are the owner is later than the time that I declared that I am or the last person who was the owner declared that they're the owner, I'm going to start listening to the one with the latest timestamp, basically. Um, and so then the problem just shifts to like, okay, synchronizing time and whatnot. And we do that. Like we synchronize your clock with the reticulum server you're connected to. We can definitely do that in a better way. I think it's accurate enough. It's like within a second or something. Like it's not like if two people are spamming on a door button or something, it will be consistent at least. Like we'll all agree on who was
The
the
final
owner.
state of the door and
Um, but
whatnot.
like real time, the person who clicked the button last maybe won't be the winner if you're really competing there. Um, but that seems to be working pretty well in most cases.
I think okay, so there's two parts of this. One is maybe the example isn't great because the ownership model doesn't really prevent you from um, having the network door that behaves well. But if I just take the question and think about it, like if you want to send um, almost like RPCs, we don't have a need for it now, but I don't know if there was like a compelling reason why you wanted to just sort of like anyone can send arbitrary data over this transport. I don't
Yeah, I mean,
think
you can
we would
already,
do
so like networked A-frame even already has this concept, and this is actually what we're using to send all of our new networking state is just over this custom data channel thing. Like we have
that.
this NN, which is like new networking message that we send. Um, and so I do think there are probably cases where you want just to like send an event off to other clients. And so I think we'll want to support that. Like right now it's supported by the fact that we're still using NAF, but like once we switch to our own custom protocol, I think having a system of just being able to send off a message seems like a good idea.
Matt suggested that maybe like, all right, maybe next stream we like build a networked door that has an animation that fires when
Oh
the
boy.
state changes and everyone's like,
Do
yeah,
it
we could do that. That's
Yeah,
actually a great
I
idea.
think that'd be a cool idea.
There's another question from Chrome Noise for cross-system communication. I assume state can be read by just accessing the relevant entity and component. For event communication between systems, however, will there be an API in place for subscribing and dispatching since it's no longer related to the DOM? So event communication between systems.
Yeah. We don't have anything yet, I would say. And the first part of your question is yes, like you can just read entity data from anywhere. Like these are just the components are kind of just these global objects. You import them and then you can read from the component array indexed by entity ID. And so like you can read and write to that data from anywhere. The way we like to do, I mean,
we have an example of event subscriptions in the network system.
yeah, like we're subscribing to like the networking events, and then we just push them onto a queue.
This is generally how we like to handle like evented APIs where we care to process the events at a specific point in the frame. So like earlier we were talking about, okay, you have to like send network messages to all the clients that connected since the last time you were sending networked messages. So I forget what sends client connected. I think like networked A-frame
Yeah,
or
it comes from
Phoenix.
like the network data from adapter, I believe, like calls that like Phoenix
Right.
adapter.
So like something emits this client connected event and we push the client ID into an array that, well, later we go through it and then clear out the array or
Yeah, I think if we
run it
were
like
to
a
come up
queue.
with like a generic event system, it would be this sort of mailbox style event thing where it's like, okay, I want to fire an event. And what that means is just like put a message into a queue and then allow multiple things to consume that queue, or maybe allow one thing to consume that queue, depends on like if you want multiple readers or whatnot. But yeah, like we right above that too, like the actual messages that come in from that NN thing, like the actual messages that come in from the network, we don't do anything with them on that event. We just throw it into a queue and we process it at the point in the frame where we want to process it. Again, like I was heavily emphasizing, like one of the most important things we're trying to do here is like understand when code is running. And so like anything that happens in an event or a set timeout or a mouse event or anything like that, we try to just like put into a place and then process it in the same spot every frame so we know when stuff is happening. And like we know that the network system, everything that happens in the network system happens before anything else that happens. Like we should be able to look at that hub systems thing and well we know the order that all those things execute in, and so we know like it's like, okay, if I create a physics body or something, well when is that going to be initialized? It's initialized in the physics system, and it means that if I care about that, I have to run after the physics system, and if I want to create it, I need to run before. So like having these points in the frame where you know exactly what is going to happen is really useful. And like we've talked about too, like how are people going to tie into this stuff, like having cut points in the frame where we say like, okay, this cut point is after networking, this cut point is after physics, this cut point is before draw, this cut point is after draw, that you can tie into. Like for now, it's really just put the thing into this file where it makes sense. What's tricky about it is like a lot of the dependencies are like a little bit transparent. Like we know that certain things have to run after other things, but like that's not really very well communicated by the code.
Yeah, we know what order all of these systems run in. They run from top to bottom, but if you are trying to insert a new system or rearrange it or change where something runs, like, okay, it is super not clear to anyone on the planet if take random system, the UV scroll system, if you're allowed to move that like to, I don't know, here.
Yeah.
I don't know. Maybe it's okay, maybe not. There's no hint about whether that's safe.
What we started to do, like if you look in the interaction, I think it's called the interaction system we have here, like when things started to actually be important, right? Like it's important that these run in this order and kind of together. So we kind of combine them together. And again, like systems are like they're just functions. Like there's nothing special. Like bit-ecs has no code that is like, oh, a system class that does this. Like it's just a system is a concept. And so like we combined these things together in here because like we wanted to make it clear that like all that, like you should not go insert code in the middle of this, unless like you really know what you're doing, like unless you're trying to add something to the interaction system, you shouldn't stick something between the held system and the, don't, what do you have there?
Oh yeah.
Yeah, like there's
I'm
some funny
responsible
names
for
in here.
this.
um,
Yeah, you're not allowed to hold an entity with both the like cursor remote thing and your virtual reality hand. And so if you ever get into that state, we had some code to like disallow that. I don't know if it ever
but like
happens. It really
it
shouldn't,
does. I
but
mean, like
like
the code we had before though was like this constraint leaked everywhere, right? It was like anywhere where we were checking for something, we'd be like, if you're holding it with your cursor but not your hand, like these
yeah,
kind of checks
yeah.
were happening all over the place and like it leaked everywhere. So by like rethinking the problem, we were able to be like, okay, like just like let's make that not happen. And we know that everything after this is like where you're going to check this stuff. So we can just make sure that by the end of that interaction system, the state of the world is valid. Um,
Yeah,
uh,
the constraint system got a lot easier, I think, because of this,
oh yeah.
because now we're like, okay, you might pick up something with your right remote. So if you do, and that thing is uh, 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 pick upable by the physics constraint, then take ownership of the object, set the relevant options on the physics body, and then add a constraint to it. Um, if we were to go check out an old version of the code and look at this, I think we did well, like a lot more
There was a bunch more.
thinking.
Also, resolve action sets, that thing in the user input system that like determines which action set you're in. Like this got a lot simpler too. It was just like
Right.
all of this just became like, does it have this component or not, more or less.
Yeah.
Um, that cleaned up a bunch.
I'd love to see a tutorial or stream about developing a bit-ecs based custom feature, door, or just a cube, local versus networked.
Yeah,
Yeah, I think that's a great idea.
yeah, we're gonna try to do these streams more, and I know this is like completely unstructured and we're all over the place. Hopefully, this is still interesting and useful. Um, but I think we definitely want to do more of these streams as we're working on the stuff and as we're um, developing new things. We've paired a lot on a lot of this stuff, and we definitely were, while we were doing it, we were talking about like I think this would be fun for people to just watch us do, and I think they'd be uh, they'd be interesting and hopefully you learn a lot.
Yeah, we hang out on Fridays in the hubs community meetups, and I'd be very open to hearing suggestions for anything that would be helpful or interesting, because those conversations we have are always interesting. So I always want to go in more in detail, and I often want to pull up my screen and be like, oh, you can build it like this.
Mm-hmm.
Like I'm very tempted to do the door animation thing. Maybe we can get Jim to, or someone, not volunteering anyone, to create a
That's a great
animated
animation.
door gltf, and we can do animation state, like networked animation state. Oops.
One other quick thing to look at, because we were talking about the event stuff, and that reminded me like the click thing we did in the camera tool system. So like the other side of events is
Oh
like
yeah.
we had code where it's like, okay, when I click this button, I want to do something, right? And it's nice to be able to write that code where I say like, button.add event listener, do this thing when I click it. But what sucks about that
Yes.
is I don't know when that code is going to run. Like when I click that button, that runs in between frames, because the way the JavaScript event queue works is like I'm running a request animation frame thing, that whole thing runs, and then I'm going to process the next thing off the event queue, which maybe is that click event. And then so my code in that click event might run there. And so like if I create an entity or something in there, I'm creating that at like a completely different spot than maybe I'm creating it at other times. So we wanted to like make, again, code execution order is like the key thing we're trying to solve here. So like we wanted a way to be able to like work with things like I want to be able to click on something and then have something happen, like the camera tool. When I click the snap button, I want to start counting down. So we have the code you're seeing on the screen. Like I think it still reads pretty clearly. Like the intent is there. It's like, okay, when I click this thing, here's what I want to do. But this happens in a completely predictable way now. Like that handling inside of that if statement is at this part in the frame. It's always during the camera tool system, and it's always at that exact time. And I know that any code that ran before the camera tool system is always going to run before that. Any tool that after the camera, like it's very predictable, but it's still expressive, right? Like I can still write, oh, when I click the snap button, here's what I want to do. And you'll see the camera tool actually became this nice kind of state machine where there's just some different states I can be in. If I'm in the idle state, well, that's when like I can click on some stuff and then do some things. And then when I'm in like the snapping state, I'll like start recording the video or snap the frame. The camera tool system actually became a lot nicer. Like if you compare this to the old code, I think this one is a lot easier to reason about, like what's going on. The old system had a bunch of event listeners for like clicking and stuff. There was timeouts for handling the countdown, and there was like events for handling the video recording stuff. Like it was the code execution flow was like almost impossible to follow. This is like very, very linear. Like I know exactly what's happening. And it's not like there's no bugs here. It's not like there's like you can't create mistakes, but like what we found while doing this stuff is like it was often a lot easier to find the issues, because it was like, okay, that's doing the wrong thing. Well, literally the only thing ever touching that is right here in this line of code, and here's where it has to be running. So like that's where the problem is, and we can drill down on that and fix it. And that was just like super useful. Started working on also some like debugging tools for this stuff. Like I have a little sidebar where I can poke around the scene hierarchy and look at the component properties and whatnot. And that's another thing too, is like all these things are just these nice global arrays you can poke at.
Is that live somewhere, or is
That's
that living
not.
in
I just have it locally. I didn't want to include it in that big PR, but I will now land it.
We talked a number of times about like we want to know when the code runs. We want it to run at a part of a given frame. Maybe we'll tease some future stream about doing things like a sequence of animations or interactions or triggers or something, but where you want work to happen across many frames and you want timeouts and things like this, but you care where in the frame that execution is going to happen. So for the camera countdown, for example, you want to change from the camera saying 3 and then 2 and then 1 and then 0 and snap it. You want that to happen over several frames, but you always want it to happen at a specific point in the camera, in the overall, each
Frame.
frame. Yeah. And you want it to happen here. So we're working on a primitive for defining some code that looks like, okay, first do this and then wait a second and do this and wait a second do this, but the actual execution of that code is always during the same point in the frame.
Yeah, we're still experimenting though, but we came up with a pretty cool thing. We were working on this yesterday actually, and we came up with, I don't know if you have the code, but we won't dive into it, like the actual execution code, but I just want to show the actual if you have it readily handy. But I kind of like where that's going, because it allows us to express we were working on the media loading stuff. So like when you load an image and then we want to do some stuff, we want to write that code in a way where it's like, okay, I want to do this and then I want to do this. Right now, the way that again, the way it works is like, okay, there's some async task, and then that's going to run, and then a promise resolves. And then, so each of those things is kind of running at arbitrary times, and it's very hard to follow the execution order. But it feels really nice to be able to write code with like async await, and I can say like, okay, like do this thing, then do this thing, and it like looks like a nice linear thing. But the actual reality of how that code is executing is just like, it's a lie, right? Like you see this like nice linear function, but actually it's executing at all sorts of different times
between frames or
mm-hmm.
Yeah. So this is like the media loading system that's in the works. It's not fully functional. It only loads images, yada yada. Disclaimer. But okay, it looks like any other system. When you add a media loader to an entity, you create a coroutine for it, is what we're calling it for now. And the coroutine is a function that is a generator function in JavaScript, which means that you can yield to pause execution of this This is new to me, by the way. I've never worked with generators or the yield keyword. I've never had to. So
Yeah,
forgive me
and I
if I
think
say something wrong.
we'll probably do a stream specifically on this at some point. But like
Yeah,
the
this
only
is the key part. Like, all right, during while you're running this coroutine, or every frame you're ticking the coroutine, and most of the time you've got nothing to do because like you're waiting for a texture to load, or you're waiting for to download an image off the internet or something, and so like this run coroutine effectively is a no op. You do nothing. But when you do have work to do, it will always happen right here in the frame. So, this log happens between on ownership loss and physics compat system. Getting
and
these
we're so
options. Yeah, sorry, go ahead.
yeah, so that like that load media function, we're gonna go through that function, but each time we come back from a yield, it's going to be at that spot in the frame, so we know exactly where that code is running. And we'll do a stream on like once we iron this out more, and but this is looking pretty promising about like how that's actually implemented and stuff, because I think that'll be interesting. But like the nice thing is like we were able to write that function that looks very similar to if we were to have written that with like async await, like the yield keywords, but like you just replace await with yield more or less, and then you get a function that is expressive. It expresses the kind of intent of like, okay, I want to do this, and this is an async operation, and then I want to do this, but like the execution order, which we're like really trying to focus on, is predictable, and so we know when each of those things is going to run. So it feels like a really nice balance between like being able to express this thing in a nice way, but still having predictable execution order. And yeah, that it's a lot to go into.
Yeah,
There's a lot there.
I'm just tempted because I'm like actively working on
It is
that.
really cool. I'm happy with where we landed. Someone asked about a timeline for like for 1.0. I honestly don't know. Like I
Next
think
week,
yeah,
we'll be
no,
done.
I think it's is going to be like an evolution. Like we're gonna keep working on this. Like I said, the first version of this where we felt like, okay, we're happy enough that like this is a direct, like, we said bit-ecs is like how we want to do this, like this JSX thing feels pretty good. That that's landed on hubs.mozilla.com, and it's going to Hubs Cloud next month. And then I think we're just going to continue working on porting stuff, but like we want people to start using it now, uh, with the caveat that it's going to change, it's evolving, and so like we don't know what the exact things are going to look like. Like maybe the templates will change up a bit, or maybe some details of the networking system will change, and so you'll have to like work with us as we.
Yeah, maybe we should volunteer some time or office hours, or just ping us and ask for some amount of help. We'll help how we
Oh yeah,
can.
definitely. Like if you want to, like in the dev general channel is like a good place to talk about this stuff, like and ask questions. Because like we want to see what people are doing, and then like we're building this as we build stuff. So like the way we implemented what we have so far is like we said, okay, let's do media frames, and so we just started doing it, and then we like landed on some patterns, and then we are like, okay, let's do camera tool, and like doing the camera tool changed a bunch of stuff. We're like, okay, like we didn't have to do that for media frames, but for camera tool, it'd be nice if we had a primitive to do this, this sort of thing. And so letting us know what you're trying to do and like the pains you're running into will inform what we need to do. And yeah, I think this will continue to evolve. And again, like there's going to be a learning curve here. Like we were definitely like, we didn't just start this and we're like, oh, this all just makes sense, we know exactly how to do everything. It was a new way of thinking, and so I guess be comfortable with the with the like the discomfort there.
There's a question: as it evolves, will you be providing migration documentation? Yes, and especially I'd like to provide kind of example code for how things should work. That's an easier target than take this thing that someone else wrote and like it should be changed to meet this. We may take some system or set of components that existed, like the media frame, the old way the media frame versus how it works now would be a good example of like a migration style doc. But overall, we're going to be you're gonna have to tell us what you're struggling to do, and like documentation maybe pulled from the back and forth that we have in Discord or on calls, because that's how we're gonna know what people are bumping into as they